Welcome back, everyone. So today we're going to go into our next module, which is factoring polynomials. If you remember, I said that factoring is basically reverse distribution. So we're going in the opposite direction of what we would do in a normal distribution property problem, and we're going to find a factor of a polynomial and write out that factor times the resulting polynomial. Okay, so when we talk about factoring polynomials, in order to get that factor, we want to find the greatest common factor that's in that polynomial. And let's just recall, a common factor is a number that is shared by two or more whole numbers. And so the greatest common factor would be the greatest number that's shared between those two or three or more whole numbers. So for example, if we want to find the greatest common factor, or the GCF, of 12 and 32, we're going to find the factors of 12 and the factors of 32. Okay, so let's do that. Okay, so we're going to have 12, and the factors of 12 are 1, 2, 3, 4, 6, and 12. And let's just make note, a factor is a number that divides evenly into the beginning number. So for example, 12 divided by 2 would give me 6. I couldn't say 5 because 12 divided by 5 gives me a decimal. Okay? 32 has factors of 1, 2, 4, 8, 16, and 32. Okay, and so what we want to do is we want to find, in order to find our greatest common factor, we want to look at all the common factors that these two have, that these two share. So they share 1, and every number is going to share 1. Every pair of numbers or set of numbers is going to share 1 as a common factor. Okay, they share 2, they share 4, and that is it. Okay, so the common factors for this example, so our common factors, which I'm going to denote CF, is going to be 1, 2, and 4. So if I want my greatest common factor, the greatest one that they share is 4. So our GCF for these two terms will be 4. Okay, now let's look at an example where we have to find the greatest common factor of a monomial. Right now we've seen how to do it with whole numbers. Now we want to transition that into finding the GCF of monomials, trinomials, and binomials. Okay, so now if we had 3x cubed and 6x cubed, and I asked you to find the GCF of these two monomials, what we're going to do is we're going to do the same thing as we did with our whole numbers. We're going to write each term, and we're going to break it down to its factors. So in this case, when you're dealing with variables, its factors are going to be more like its prime factorization. So remember, prime factorization, or its factorization of getting it down to all of its prime factors. So here, 3 is made up of 3, and x cubed, remember, is just x times x times x. For 6, it's 2 times 3, which gives us our constant, and then x squared is just x times x. So if we wanted to find our common factors, we have a common factor of 3, and we have 2 of the x's. Okay, so in this case, our common factor, or our GCF, is going to be 3 times x, which gives us 3x squared. Okay, so now let's look at the second example. Now we want to find the GCF of 4x squared and 5y cubed. So again, we're going to write each of our terms, and we want to break these down. So the factors of 4 are 2 times 2, and x squared is x times x. For 5y cubed, the factors of 5 are just 1 and 5 because it's a prime number, and y cubed is y times y times y. But wait a minute, here we don't have any common factors. Nothing in between our two terms matches up to where we had a common factor like we did in our previous example. So in the case where your two terms don't have any common factors, your GCF is going to be 1. Okay? Because I can always write 4 as 1 times 2 times 2. Multiplying anything by 1 gives me back that same thing. Okay? So here our GCF would be 1. Okay? Now we're making it a little bit trickier. Remember, we always move from monomials to binomials to trinomials. So here we have a trinomial, and as I said earlier, factoring requires us to do the reverse distributive property. Here we need to factor this somehow to where we pull out one common factor from all 3 terms. So what I'm going to do is I'm going to take each term separately and find its factors. So 10 is 2 times 5 times y times y times y. 20 is y squared. 20y squared is 2 times 2 times 5 times y. And 5y is simply 5 times y. So here we have common factors. Let's highlight our common factors. We have a common factor between all 3 is 5 and 1y. So our common factor is 5y. Our GCF is 5y. Okay, so this is the factor that I want to factor out of my expression. So what I'm going to do is I'm going to divide each term of my expression by my GCF. So let's just write our GCF so that we know exactly what our GCF is. And now I'm going to take and I'm going to divide each of these terms by my GCF. Okay, so when I do that, I'm going to go through this thoroughly so that you see what I'm doing in each step. When I do that, so what I'm going to do, I know that my factors, I have my prime factorizations already. So this is going to be 2 times 5 y over 5 times y plus 20 is 2 times 2 times 5 times 2 y times y over 5y. And then this is just 5y over 5 times y. So here, now that I've written out all of my factors, I'm going to see what cancels, because this is doing division. So remember, division is seeing the same thing as what cancels out in the numerator and the denominator, or what they have in common. So here we have a 5 that cancels and one of the y's that cancel. Here we have a 5 that cancels and one of the y's that cancel. And here the 5 cancels and the y cancels. Okay, so my resulting polynomial is going to be 2y squared plus 4. 2 times 2 is 4, and I'm left with 1y, 4y, minus, now 5 divided by 5 is 1, and y divided by y is 1. So this the result of this cancellation is going to be just 1. And so my final step, once I simplify and cancel out everything that cancels out by the GCF and I get my resulting polynomial, my final step is to write my greatest common factor on the outside. So I'm going to place parentheses around my simplified expression, and I'm going to write my resulting polynomial, my GCF, on the outside. Because in order for this to be the correct solution to our example, if I were to distribute this 5y back, I should get my beginning expression. Okay, and so this would be my final answer. Okay, so now let's look at an example. Here, our example is already kind of pre-factored for us already. They've pulled out the terms that they have in common. But if you notice, the GCF is now a binomial. And so now you're going to start seeing examples where your GCF is no longer a constant or a monomial, but now it's a binomial, such as x plus 3 is going to have two terms. So here, when we have an example that has a common binomial factor, what we're going to do is we're going to factor out that common term. Okay, and I just want to make note that, remember, x plus 3 is equivalent to 3 plus x by commutative property of addition. We know that we will get the same result. Okay, so that's why these two are equivalent and common binomial factors. And so what we're going to do is we're going to factor that out. Now you can choose to write it either way. I'm going to write it as x plus 3. And then what I'm going to do is I'm going to group my resulting, my leftover terms. So my leftover terms will be this and the operation. So I'm going to have 5x minus 4. And this would be my factored polynomial. Okay, one thing I want to point out, whenever you get to this step where you think you fully factored your polynomial, what you want to check for is that there are no terms and there is no more GCFs that we can pull out of each term. So here these will be fully simplified. Just like when we were adding, subtracting, and multiplying polynomials, before we boxed in our answer, we made sure that we had no like terms and that everything was simplified. And you want to do the same thing here. You want to make sure that there's nothing else that you can factor out of these two terms. Okay, and finally, let's look at now the last thing that I want to discuss today is factoring by grouping. So factoring by grouping occurs when you have 4 terms in your polynomial. In all of our previous examples, we had 2 to 3 terms. The most we have is 3 terms. Here we have 4 terms, and what we're going to do to factor is we're going to group the first 2 terms, and we're going to group the last 2 terms together. And then we're going to pull out our greatest common factor. So for example, in the first one, we want to find the greatest common factor between 2g to the 4th and 10g cubed. Here we have 2 times g times g times g times g. And after a while, you won't have to do this. You can just do it in your head and find the greatest common factor. And here we have 2 times 5 times g times g times g. So our greatest common factor here is going to be 2g cubed. And notice that anytime we have 2 variables where our exponents are not the same and you're trying to find your GCF is always going to be the variable with the lesser exponent. Okay, so here I'm going to factor out a 2g cubed, and I'm left with g plus 5, right? Because if I were to distribute this back, I need to get this beginning expression, and I do. Okay, and here there's nothing in common between g and 5. So remember, if there's no common factor, the greatest common factor is 1. And so now we see that we have a common binomial factor, or CBF, and so we're going to factor that out. And I'm going to group my remaining terms together. Okay, and so this is my resulting factored polynomial. Okay, so now let's look at one last example. Again, we're going to group the first 2 and group the second 2. I'm going to pull out my common factor. So here my common factor between 3 and 15 is 3, and then between x cubed and x squared it's x squared. So I have an x left over, minus 3 times 5 gives me back 15, and x squared times 1, so I don't have to put anything else. Okay, now here, between 2 and 10, my greatest common factor is 2, and I don't have an x in this one, so I don't have to worry about my variable. So now when I pull it out, I get 5 minus x. Okay, and so notice here, x minus 5 and 5 minus x are not equivalent because remember, with subtraction, we cannot use the commutative property. All right, so what I want to point out is that x minus 5, if I were to multiply this by -1, I would get negative x plus 5, which is also the same as writing 5 minus x. So I can rewrite this as -1 times x minus 5. Okay, so what I've done is between step 2 and step 3, I've changed 5 minus x to -1 times x minus 5 because the goal of factoring by grouping is to make sure that whatever binomial is in our parentheses is the same, so that way we can factor it out. Okay, and so now I just simply use my, I factor out my common binomial, and I write my resulting term. So 3x squared and -2 times -1 is simply +2. And so here I cannot pull out anything, so this is my common factor. Okay, and that is the end of today's lesson.